alaikum. Thank you very much for giving me the floor at 4th International Conference on Physics for Sustainable Development and Technology. And my topics is design approach of an LTA system as aerostat for weather monitoring at a specific altitude. I'm Tasnim Rana, and with me the work is done by Dr. Shahidul Islam. The main focus of the work is that how can we monitor the weather condition and collect the data from a certain altitude and for a long period of time. The main focus is that how can we develop a LTA system. LTA means lighter than air, the air which has lighter than uh, air capacities to flow and create the buoyancy forces. So using the buoyancy forces, we can withhold the system on air, and with that we can collect the data. The main inspiration of this work, the motivation of this work is that there's a lot of scope and necessity of collecting data at a certain altitude for a long period of time. But for that we use drones, aeroplanes, and other costly ways to collect the data. But if we can use the LTE system as Aerostat, then we can have a lower cost for having such kind of data collection from a certain altitude. How can we design it? For using the LTA system, we mainly focus on buoyancy forces, and this is the equation of buoyancy forces, and this is mainly dependent on the density of lighter than air gases. If we use helium, then we'll consider the helium density of helium, and mainly with the buoyancy forces we can withstand the floating devices and we can monitor the system. So there is a weight, and calculating the payload we can calculate the buoyancy force. So if we can create the volume for that kind of gas holding, and it will create the buoyancy forces, and these buoyancy forces will withstand the system on air at a certain altitude. And so this is the main concept, and there will be two modules. One is air module and another is ground station. And at my work, we have simulated the system and find out the range of interest from 10,000 to 1 lakh, so that within this Reynolds number we will have a stable coefficient of drag, and using this value we can have the drag force, and also we can use the CD at the buoyancy force equation. So we can have a certain envelope which can withstand the system, and at a certain altitude it will have its stable condition of flying. This is the final condition of flying, and this is the data taken from 50 feet height from the ground. And for further work done, we can make a control system which can make the system more stable, and this is the reference. Thank you very much.